I'm delighted to welcome you today to our webinar entitled The Winds of Change, Unlock the Power of Airflow Management in the Data Center. While I won't claim to be an expert on this topic, I'm confident that we have in today's participants representatives of two of the organizations, Legrand and Equinix, which best represent a dedication to both technology innovation and sustainability objectives within the global data center industry. And I'm very much looking forward to them sharing their considerable knowledge over the course of the webinar. From Legrand, we have Mario Contador, Data Center Solutions Marketing Manager. Mario started as a cabinet and containment engineer with a major focus on designing energy-efficient solutions. He originally worked for Minkels in 2017 and transitioned to Legrand in 2021, taking the marketing lead for the rack PDUs, KVM, cabinet, and containment solutions that Legrand deploys in Europe. Mario's main focus is not only to pave the way to market for Legrand for these product categories, but also to define what the future of Legrand looks like in the coming years, with a view to what the market will demand in the years to come, and to establish how Legrand will bring unique value to its customers for these solutions in the future. Arjan Westerhoff works as the Principal Operational Sustainability at Equinix. He's been in the data center industry since 2000 and has almost 20 years of operational experience. Arjan has worked at Equinix since 2020 and is currently in the role of Principal Operational Sustainability, supporting teams over the world in their journey to become more energy efficient and sustainable. His initial focus was on energy efficiency, and he's now working on water usage and measurement and reporting according to the ISO IEC 30134. Indeed, Arjan is part of the ISO IEC 303134 committee, which is the owner of data center KPIs like PUE, WUE, and ERF. He's also part of the NEN Commission, which is the Netherlands Standardization Institute. And with the introductions made, let's get started. Although before we do, just a quick reminder that if you have any questions as the webinar progresses, you're able to send these through to us, and Mario and Arjan will answer them during our Q&A session at the end. And any questions which we don't get around to will be answered offline over the next few days. So if we can start perhaps with a little bit of scene setting and some context before we tackle today's topic. The European Commission has been working for quite some time on its energy efficiency directive. As far as data centers are concerned, there was some important news released, I think, in March this year. I believe that the EU is requiring all data centers to report on numerous data center metrics related to energy and resource efficiency. Metrics covered include power usage effectiveness, water usage effectiveness, and the energy reuse factor, or the renewable energy factor. So perhaps, Mario, you can tell us a little bit more about what has been going on.
Sure. First of all, thanks for the introduction. Thanks a lot, and thanks for having us. So, introduction made. Thanks a lot. I think this is a very good point, and it's a very good timing also that we're having this conversation today, because this is news, right? So maybe not all the attendees know about this. And this is something that the EU has been working on for quite some time already. So since 2023, this was in the making. But as you say, it's quite recent that they said, we are going to start asking data centers to report on certain metrics. Some of them you have mentioned already, like PUE. This is starting in September this year. So I think, if I'm not mistaken, it's September 15th that this is happening. But I would like to say, it's not that you should just stop there in the reporting. We also have seen certain countries going beyond. So I can give you the example of Germany. Already in 2023, they also put out a legislation that will enforce data centers not only to report on these metrics, some of these metrics, but also to reach a certain value. So in German data centers, if they start operating from July 1st, 2026, if that's the first day of operation or after, the PUE value that they have to reach is 1.2 or lower. So what I'm trying to say is that don't just wait until the law it's coming to you. You know, it's like countries are already taking a step ahead to this legislation, and not only to new data centers, but I know also that for Germany specifically, even the data centers that existed or were running before that date, they will also have to reach a certain PUE value. So for these data centers that were already existing, this is going to be of course, because you have to do an investment, the transition, it's going to come at stages, but they will have to reach a PUE value of 1.3 or lower by 2030. And again, this is just Germany, but I mean, we have Arjan here, who's from the Netherlands, so maybe he knows something about this in the Netherlands as well. I don't know.
Hey everyone, thank you for the introduction. And yes, indeed, in the Netherlands, a lot of things going on the PUE. We're talking about PUE of 1.16 in the Netherlands. But next to that, there's no reason not bringing down the PUE. There's always room for improvement, I would say. The global average PUE is quite high for some time, but we'll show you later on in this presentation. But there's always room for improvements, and it's indeed not only about reporting, but how can we do better? And this is indeed why we have this webinar about the airflow management, where it starts in the data halls. But yeah, Mario, that's indeed what we need to talk about.
Yeah. And I would like to say also, I mean, we've talked the Netherlands and Germany, it's the example that I was aware of, but I'm from Spain, not for data centers, but in the European Union, when it comes to different legislations of all sorts and kinds, it is quite often the case that, at least for my country, we absorb, or this legislation that sometimes take place in northern countries, they come later on to our country. So I will also recommend that, at least to these countries where we don't have such a strict values to reach, that they start preparing for this, because my opinion is that this is going to come sooner or later to all countries across the EU.
Yeah, next to that, Mario, we just need this legislation to become better. We shouldn't be against it. We need to embrace it. It's good. So I'm happy, yeah, to work with the regulation, I would say, to do better.
Okay, I mean, my immediate reaction is that these are very challenging values, and I think that the latest Uptime report shows that average PE stands at about 1.58, and that's been a fairly consistent figure, I think, for the last decade or so. And these average values are clearly a long way from what is required. So yeah, how big is the problem, I suppose?
So 1.58 you mentioned, that's almost a PUE of 1.6. If you look to the total energy usage of the data center with a PUE of 1.6, only on average 63% of that energy can be used by the customers. When you look to a PUE of 1.2, it will be increased by 20%. So total energy for customers will be 83%. So there is a big win for all the data center companies. So even decreasing the PUE, become more energy efficient, because there's way more energy you can use for your customers. And especially now in these times where we have issues in a lot of countries with a shortage of electricity. So in 2020, we started with a phased approach program. And this program consists of 4 important phases. Phase 1 is about air containment within the data halls. So make sure you have your air containment in place together with your blanking panels. And only when you have done that phase, you can go to phase number 2, which is about CRAH optimization. With the CRAH optimization, a lot of people think we're going to increase the temperature. And yes, that is the case. But maybe even way more important is the decrease of fan speed. So do not overflow, I would say, the data halls. There are a couple of other technical things you can do, but those are the two most important things on CRA optimization in the data halls. And then phase 3, it's about the distribution optimization. So if you have a chilled water system, how are your pumps operating in the situation? And then have a look to your cooling generation plant. A lot of people start looking at the cooling generation plant, for example, an air-cooled chiller from day one, but you need to start at the data halls. And when you have been following this approach, you have a cascading effect of energy savings, which is really great. So in general, it is when you have your containment in place, when you can increase your supply air temperature. And when you have increased your supply air temperature, you can increase your water temperature. When you have increased your water temperature, you will have an increased total hours of free cooling available. So less mechanical components on, for example, an air-cooled chiller running and consuming a lot of energy. And next to that, there is more opportunity for providing heat to the district heating network. But there's a cascading effect. So a simple change on the CRA unit or on an aisle containment will have a big impact in the end of the program.
You've just there talked about, I think, a phased approach, and you said the first step is optimizing air containment to be able to reach the required PUE levels and other KPIs. And that's obviously what the EU is demanding in the coming years, or potentially some countries are already enforcing. And it's this first step, unlocking the power of airflow management in a data center, that's obviously the main focus for our discussion. I guess the starting point is, without managing airflows properly, any other measures taken are potentially unlikely to be truly optimized and could actually fail. So perhaps the pair of you could help us understand what it is that data centers need to do to have this properly addressed, to be successful, if you like, in this first step, optimizing the air containment.
Sure. Oh, sorry.
Please go ahead, Mario.
Yeah, sure. So, I mean, Arjen has mentioned already a bit of this. So at our end, as Legrand, with the brand Minkels, we take care of the design of the cabinets and the containment, which is, as he mentioned, as Arjen mentioned, the first step that you have to take a look at. You already maybe approached a bit more in details because it just comes natural, the things that you have to do. But at our end, what we did is that we are also aware you have to be very conscious about the design of your solution. So there's a lot of effort in thinking what your product should be looking like, what the design should be, to optimize its performance. Because many people may tell you or may think that a cabinet or a containment, it's just a box. We did not look at this in this way. So for this first step, when we were in the design phase of the cabinet, I remember that we brought a lot of customers in so that they could provide us with feedback, because of course you have a lot of iterations of the product. And I remember Equinix, I don't know if it was Arjen, but I remember Equinix was in the picture, and actually there was a talk about it's minor tweaks, but it will affect how your product is dealing with the airflow that it's going through the cabinet. So these things we took care of, and the feedback that we got from customers was very, very valuable. But before jumping into, because he already mentioned blind plates in a rack, I just want to make sure that, because that everyone is on the same page here, because he has mentioned containment. And just again, just to make sure, I am assuming everyone knows, but containment is the separation of the cold and hot airflows in your white space. And you can have two solutions, whether it's cold containment or hot containment. And cold containment, what you will get in your white space is that you have cold air going through a raised floor, and then you will contain it in an aisle so that you have a homogeneous situation where you can then spread this cold air through the servers and cool down your IT equipment. Hot containment, again, just for clarifying purposes, it's the opposite. In this case, what you want to do is to isolate the hot air. So what you do, how you do this, normally what we see now is that you have a fan wall in the white space area that it's pushing cold air into the white space. And then this cold air will go through the cabinets again, and this hot air, you will have it contained and it will go through a vertical containment. And then you can reuse, maybe Arjen gives you more details here, but you can reuse this throughout your entire facility, this hot air, because it goes through a false ceiling. But that just to make sure that that's first, defined hot, cold containment. And then, as Arjen said, first step you take is blind plates, right? That's like a very big, important thing when it comes to rack airflow management, I'll say. I think that's the first advice you normally give as Equinix, right, Arjen?
Yeah, that's correct. And there are a couple of things. So we already mentioned that it's really important to keep hot and cold air separated. And in the end, it doesn't matter, it's going to be cold or hot air containment. So why? Maybe we need to discuss a little bit. Is it so important? The moment you're going to separate those hot and cold air, there's no mixture anymore. You can supply with hotter air than you did in the past because there's no mixture again. What you want to prevent is that hot air from the back of the equipment will be drawn back to the front of the server. That is what you want to prevent with these blanking panels, together with our containment.
Yeah, this recirculation, I'll say it's the key thing. So you have a lot of measures that you have to take to make sure that this hot air is not coming back. So Arjen, you've mentioned the blanking panel, so that's the first gap to cover, which is between the 19-inch posts. Then one thing that we do with our Nextman platform, it's what we call our airflow management kit. So it's not only the gaps in the 19-inch that you have in the middle, but also the gaps from the 19-inch to the perimeter of the cabinet, so that the sides and the top. Our solution, so what we do is we make sure that these gaps are perfectly sealed, So this is what you will call front to rear airflow. But even though I can imagine this is well known, one thing that I want to mention here in this front to rear airflow is that it is very common practice to use brushes on these sides, because you want to run cables from front to rear. That's common, but it was our experience, and now it's something we have tested. So it's proven, it's data proven by a third-party lab. We wanted to make sure that this is the case, that brushes are not airtight. So when we are talking about, this next level, when it comes to efficiency and levels of PUE, it's now your job. It's in tweaking these minor things, or what might seem like minor things, in your design. So for that, what we put out there, it's brushes that are much more airtight for the front to rear airflow. So these gaps must be covered, and we do recommend to go for something better than brushes. And you have more things to cover in the cabinet as well.
Yeah, let's not forget, for example, the gaps in the floor at the bottom of the rack for the cabling coming into the rack. Make sure those gaps are sealed, and that's together with when you have outside the rack or our containment a PDU or something like that. Also, those gaps need to be closed. Sometimes I've seen a CRA unit at the wall. There was a gap between the CRA unit and the wall.
Okay.
And the air came out from the raised floor, and so make sure that the entire room is sealed, I would say, to keep it really separated.
Yeah, and for us, I also want to, again, it was a big, how do I say this, like a big red flag, the amount of brushes that we saw across data centers, So we keep on working on improving those entry and exit points. So we have finalized, for example, this is new to the market. just so you know. But because we tested this, we have finalized a new design for an accessory that allows cables to enter or leave the cabinet in a much more airtight way. So we can provide the attendees with a white paper on this later on if they ask for it. But it's proven to perform 80% better than brushes to make sure that their solution is airtight, so to avoid this recirculation. So a lot of things to pay attention to, I think, and then it goes also to the best practices of the customer. It is, as a marketeer, I tend to check all the information that is out there. So for example, I know that Equinix is quite proactive in communicating to customers of best practices. Like I saw recently what did you call it? Like a customer guideline on what to do or installations, I think.
Yeah, indeed, it's the new customer guidelines, customer installation guidelines, I should say. Recently published, indeed, because the thing is, we are in this together. We as a data center company can't do this on our own. We need to do it together with our customers, but also with suppliers like Legrand. So we need to share best practices, and we need to explain why we are doing this. It's about saving energy. It's about legislation. We need to work with higher temperatures, and those higher temperatures can only be met when the airflow management is in place. Otherwise, you will have issues.
Okay, so in summary, if I've understood you both correctly, I think when it comes to achieving a truly optimized, energy efficient data center environment, the type of containment solution specified is crucial. The way in which it is installed is equally important, and also the way in which it's maintained is important. So I guess even the tiniest gap, I think you mentioned there, the slightest installation error or a layout change at a later time can have a significant knock-on effect when it comes to impacting the energy efficiency of the containment solution, which obviously means the whole data center in effect. So, and the EU Energy Efficiency Directive, which we've discussed, and other local, national, regional regulations beginning to bite, optimizing air containment is not something that can be ignored. But I mean, that's what I've taken away from this, but perhaps each of you in turn might just give us what you think is the one or two key takeaways from the discussion you've had.
Yeah, I mean, I think that's a good summary. If I had to take just one thing, I mean, Arjen has said something which is good, which is that we are all in this, and that there is no reason for not, improving your PUE, your data center, and the way to do it. What we've been discussing today is these minor tweaks, these airflow management solutions. It's something that it's heavily overlooked. So please pay attention to that. But what I will say is that you shouldn't wait just for legislation. In this case, we have it on top of us coming, but you shouldn't wait for legislation. I want to make this very clear, to be enforced on you so that you take the step. It's many times legislation might not be up to the standards that you should be meeting. If I give you an example that it's not with airflow management, that has nothing to do with airflow management, but with cybersecurity. So you will have a regulation which is called FIPS 140-2. I think version 2 was this legislation, and this is from 20 years ago. It's been only recent news, not so long ago, that you have the new version, the version 3. So just imagine, and we're talking cybersecurity here, how large of a gap you have between the first thing that you had to comply to and the new one, and the possible risks if we are talking airflow management inefficiencies, in here cybersecurity possible risks that you might be, stepping into if you just wait for a legislation to tell you, hey, do this. I think that would be my key takeaway.
Yep, and Arjan, have you got some thoughts?
Yeah, for me, it's what I already mentioned. We're in this together, and this webinar is about airflow management, and the most important thing is keep hot and cold air separated, and think in opportunities. And one thing I did not mention yet is that when you have your airflow management in place, that's also not a positive thing. It could give you more redundancy. It could give you a more stable cooling installation, and that's only on the positive, that's good. So yeah, let's work on this together.
Okay, well, thanks very much for the discussion. We have had a few questions come through while you've been talking. So if you're good to answer those, I will fire away. Obviously, if one or both you want to, that's absolutely fine. So the first question we've had in, fairly simple, I guess, is does the EU legislation apply to all data center sizes, or is there a threshold that's been specified?
Now, so there is a threshold indeed. So 500 kilowatts of IT, that is the threshold. If you have 500 or more, you need to report.
And just as a matter of interest, do you think over time that might reduce, or do you think that will be a fixed threshold sort of for the foreseeable future?
Actually, indeed, I think it will be less in the future. Reason for that is that there are still many data centers with a lower load than 500 kilowatt. So many of them, and we already know that these data centers are not that efficient like the bigger data centers. So there's a lot to win for the data centers, computer rooms with less than 500 kilowatt. So indeed, I think it's just a matter of time.
I think you're saying this is a very good point. Not about the threshold, but that there is a lot to win in smaller data centers. We have a colleague in common, actually. So that we've met with him, and I remember he said, if you are an IT guy, you see servers when you walk into a data center. If you are a power distribution guy, you know where to look at. I remember him saying, when you come from the world of airflow management or cabinet design, all you see when you walk into a containment, it's holes, it's gaps, things that are not properly sealed. And I think the smaller data centers, they have not, they have more things to pay attention to. And as you said before, Arjen, there's no reason why you shouldn't pay attention to this, even if you don't have this threshold. So I've seen these gaps, or I have had conversations where I had to convince people to go for containment. It's unusual, but it's still happening depending on in which country you are based or the level of expertise. So regulation might bring this thing down, this threshold, but Arjen mentioned it before, like, why wouldn't you do it already?
Okay, second question we've had in is, I guess, one that people often puzzle over perhaps is, you've mentioned both hot and cold aisle containment, and the question is one or other of those approaches better than the other, or does it very much depend on what you're trying to achieve? I don't know.
I wouldn't say, sorry.
Go ahead.
Okay, sure. I wouldn't say, I mean, we have two perspectives here because I'm from the designer, or the manufacturer world, so to say. So as a marketeer, I go and visit customers from time to time. And then in my eyes, it's what I see, it's the conversations I have. As a manufacturer, my opinion is that there is no better or worse. Arjen said it before, it's an important thing is that you maintain the airflows separate. That's the most important thing. And it's normally given to you by the design of the building. So at least in the conversations that I've been having lately, I would say I've seen a trend of more and more hot containment, but I wouldn't prioritize it over cold containment for any given reason. I don't know what you think, Arjen.
There might be a small difference, but indeed it has to do with the design and all the principles. And if we are already doing a really good job if everybody has our containment in place. I'm already happy with that. So yeah, let's get started, I would say, with the last data centers which don't have our containment yet.
We've also had a couple of questions on the temperature to reach. It seems some of our attendees have read that 27 degrees is the target temperature. But do you know anything about this specific number? Is it actually a legal requirement or just something, the temperature to aim for in general? And I guess the sort of follow-up to that, and to Equinix specifically, in terms of going to this 27 degrees, if this is something with which you're focusing on, what's the benefit of going to this temperature that you've seen so far? Is there anything you can share?
Yeah, so in general, already explained, and the moment we're going to increase the air temperatures, you have cascading effect of energy savings up to the chillers. So it's about energy. Next to that, there's also a kind of guideline already available on the ASHRAE. ASHRAE states that it is possible to operate with 27 degrees. And next to that, in the Netherlands, for example, it's law at the moment. Data centers need to provide supply air temperature not less than 27 degrees. So we just have to do it. And that's a good thing.
Okay, and we've just got time for one final question. Someone's asking, what would be the key things to look for, the key questions to ask when people are evaluating a potential containment solution? Yeah, what are the things they need to, what are the answers they need to be hearing from who they're talking to, etc. So it'd be good to understand that.
So for me, the key.
Please go ahead. Yeah, so we're having the same thing. So please go ahead, Arjan. My pleasure.
For me, the key things are really, as mentioned already, keep the air separated. That's one thing. But next to that, fire safety is also a very important topic. We have not addressed that topic yet in the webinar, but not all products are allowed due to fire regulations. And maybe the last one, it needs to be maintainable and a kind of modular. You need to create and build something you can deinstall or take components out when you need to do installation work, for example.
I was going to go exactly to the same point, funny enough, or almost the same point. From the manufacturer or designer point of view, I would say you need to go for solutions that are not we're talking about optimizing the airflow in your solution to a point that it's going to be very demanding. Or, you've been running with, I would say, way lower temperatures, your data center. This might be 22, 23 degrees. You need to be aware that your solution, it's serviced by professionals that know what problems you can have in your data center if you have to integrate perfectly in an airtight way columns or lights or cable management infrastructure that is going through, fire extinguishing systems whatsoever. This is it's not just a box that you have to put in place. So I would say, you have all these challenges, and that's something you need to make sure that the person or the provider of your solution, it is aware of. And as Arjan said, modularity. That's something that it's very important to have in mind. You're going to have cabinets that are going to last long, and you have some other devices that are going to change more frequently. Maybe also even the cabinet size, because you want to optimize the floor space, the real estate you have in your building. If that's the case, I think it's good that you inform the person that it's working with your containment solution, so that you get a design that it's already considering those future changes, that level of modularity, and you can still maintain the airtightness of your solution. I think that's a very good point that Arjan made, and modularity it's key indeed.
Okay, thanks very much for answering those questions, Jens. I think that's all we have time for at the moment, but as I did say at the start of the webinar, any questions that we haven't been able to get around to, they will be followed up over the next few days, so we're not ignoring them. They will be answered at a later stage. And in closing, I would like to thank both Mario and Arjan for providing us such an entertaining, educational and insightful webinar today. I'd also like to thank, I think we had about 200 or so registered for the webinar. I hope most of you have joined us today, and some may be watching the on-demand video over the next few weeks. But thanks to all. I say again, Mario and Arjan, and for you for watching. And yeah, goodbye. Thank you.